the focus of this lesson is on graphing using transformations, and this time around we're going to be graphing using a combination of transformations. So there's more than one transformation happening to your parent function. So the very first step is to figure out, well, which is my parent function? What is being altered? What are the transformations occurring upon? And so if we look here at our g of x equals 3 minus x plus 4 cubed, you can see in black here that I have that x cubed piece. Well, that's our parent function f of x. So f of x is x cubed. So if we're going to graph by transformations, that is our starting point. So I'm going to go ahead and create a t-chart for f of x. And I know the general shape because that's one of my library of functions. So I'm going to pick a negative value, 0, and a positive value. And then I'm going to cube those values because it's a cubing function. So negative 1 cubed is still negative 1, 0 cubed is 0, 1 cubed is 1. So I get the ordered pairs negative 1, 1, negative 1, 0, 0, and 1, 1. It's kind of curved like that. That's my parent function f of x. And then I want to apply the remaining transformations that I have. So if you look here just at the g of x, you can see that you have this plus 4 piece, you have this multiplier by a negative 1, and then you have plus 3 here. So you have 3 different transformations. So that's what we need. We need to do those 3 transformations to this graph. And you can kind of tell from this format what the transformations are, but I'm going to change the order a little bit so that plus 3 is at the end of the function. And so that might help us visualize a little better what the 3 transformations are. When you go to actually physically graph it, do all your shifts last. There are a couple ways to do this just to be consistent with how I teach it in class. That's what I would do, is your shifts last. So then now I need to think about, well, what's happening to my function? Well, I have my f of x is x cubed, but it doesn't say x cubed. It says x plus 4 cubed. So one of my transformations is my f being evaluated at x plus 4, which gives me that x plus 4 cubed piece of g of x. Okay, and in that case, if I'm adding 4 to x, we know that that's a shift because of the adding. And then it's happening to the x, so we know that it's horizontal, and because it's adding, we know it's left. So this is a shift left 4 units. That's one of the 3 transformations we have going on here. But then notice also you have this little multiplier of a negative 1 in front of that x plus 4 piece. So if I put a negative 1 in front, that means I'm negating my entire function. So if I'm negating my entire function, a negative on my y's, we know that's a reflection across the x-axis. And then last but not least, we're taking that function and we are adding 3 units to it, to that whole function. So we're adding 3 units to that whole function. So that's the left-hand side of that equal sign. So if I'm adding 3 to the whole f of x, I know that's vertical. And since it's adding, I know it's up. So it's up 3 units. So at the end of the day, these are my 3 transformations. I'm going to do my shifts last. So I'm going to just start with the reflection across the x-axis first. So this is your x-axis, this is your y-axis. The reflection came from the negative, so I'm going to do that in green. Notice the vertex will not change. And then if we reflect across the x-axis, This point that was 1 above is now 1 below. This point that's 1 below is now 1 above. And so I'm just going to kind of draw that in. And then as far as doing the left by 4 up by 3 next, it doesn't really matter. You can kind of do whichever you feel. I'm going to go ahead and go left 4 units. 1, 2, 4, 2, 3, 4. And so that shifts me left 4 units. And then last I'm going to do my up by 3, which was in red. So as far as a final graph is concerned, it's your last transformation you do. So this here in red is my final graph because it takes into account all 3 of my transformations. So this is my g of x at the end of the day. So one thing you could do is you could label those points. So it would be -3, 2, -4, 3, and -5, 4. And if you want to know if you did your transformations correctly, you could plug these in to your g of x. So plug in the x values and see if when you apply all these transformations you get these y values back, and in fact you do. So that's how you know you've done your graphing correctly. So as a final graph, by graphing by transformations, our black f of x has transformed into our red g of x, and that would be our final graph, and the rest of it is our working graphs to get there. The only other thing I wanted to mention is I had done all of this work off to the right here showing the type of transformations you have, but when we labeled the 3 transformations kind of with these little arrowheads, you could go through it that way as well and see, hey, I have a negative being applied to the entire function, so I know that's a reflection across the x-axis, so think opposite letter. You could see that you have this adding of 4 to an x value, so you know it's a shift horizontally, and since it's adding, you know it's left 4 units. And you can also see that you have this adding of 3 not to the x's but to the whole function, so you know that's a shift vertically. And then since it's +3, it's up 3 units. So you can see it all right here. You don't necessarily have to write all this out that I did in on the right hand side here, but that kind of gives you the notation of the transformations that are happening as far as according to the rules go. So either way, as long as you can locate your types of transformations and then apply them by doing your shifts at the end and all your other transformations first, then you should end up with the final correct graph.